Now let's have a look at a hypothesis test on the slope. And just like the other ones we've done, we have our 5 steps. We have our hypotheses, our significance, our data, our p-value, and our decision. So the null hypothesis, and in fact if it's written in mathematical terms, we say beta 1 equals 0. And the formula for that is a bit later on. We're going to be talking about this bit here. You don't need to know this stuff for the test, but it's just useful for you to have seen it, so that if you see it in another stats course, you don't sort of go, oh, I've never seen that before. Mind you probably will anyway. Okay, so what we're saying is that we're saying there's no relationship between them. And it might be some of the lines that you fitted in the Module 2 quizzes were pretty flat. Do you remember that? Some of them had quite steep slopes, but some of them were pretty flat. There are about 5 different ones in the NPQs, and actually you'll find they're the same ones that are being used in the NPQs for Module 6, but this time rather than fitting the line, you have to fit the line and do the regression. So the alternative hypothesis is that the slope is not equal to 0. So we're not saying it's really steep, we're just saying, is there an effect? So if the slope is different from 0, that means there is an effect. That was just me. And if the slope is not different from 0, that means there is no effect. So hours of television watching does not affect the level of debt. Okay, so we've got alpha equals 0.05. We collected the data, and the data was used to fit the line, and we got a p-value of that, which comes to 0. So p is low, null must go, so it's a little p-value, so we reject the null hypothesis, and so we can say there is a linear relationship, because we're interested in lines here, not any other kind of relationship, between the number of hours of television watched and the amount of debt. Note, I am not saying that debt causes the number of hours of television watched. I mean, I'm not saying the other way around, because it may be that people who are badly in debt are so depressed that they go and watch television all the time. We cannot assume causation unless we actually do an experiment. Okay, so we've got our hypothesis test, and now we'll do our confidence interval. I'll get my page loose. Okay, so you did confidence intervals in Module 5. And it's just the same as what you did then. You did confidence intervals on a mean and on a proportion, and this is a confidence interval on the slope. So it's saying, in the sample, this is the slope. This is the line that best fits this sample. If we had all the data for the population, all the people in whatever, America or whatever, who had how many hours of television they watched and how much debt, and we put a line through it, what is the range within which we are 95% confident that the slope will lie? Okay, so the resulting equation was that. So that comes from Module 2. That's when we're talking about the sample. But now we're talking about the population. So for the population, we use a confidence interval. So we say, using a 95% confidence level, we can say that the mean level of debt increases by, no, it says increases because that's helpful to know as well. Go back to this one here. So we're looking at these two numbers here, 2213 and 2950. Okay, so we've got increases by between $2,213 and $2,950 for each additional hour of weekly television. So it's the same interpretation, but instead of just having that value, 2581, which is the correct value for the sample, we instead say, what can we say about the population that is inferred from the sample? So we use the sample information to make that confidence interval statement.